Hello, gentlemen. Mr. Novak here, just following up on a request from a student. Yes, please bring them in. Keep them coming in, I should say. Um, so this one is a rectangular prism. So let's start drawing on that rectangular prism. Now, one option is to do an isometric drawing of a rectangular prism. So this is an isometric drawing. So we have a base which has whose length is twice its width. So let's call that W. Because as you can see, if you go and read ahead, you'll realize they want everything in terms of W, and its length is twice. And if I was to draw that same, but slightly above, well, actually quite a bit above, because the height is 3W. There you go, 3W. So there's the dimensions of, so the start. So we've done, so, and then part A, what they want, so we have width equals W, length equals 2W, and height. Now, as you can see, length, width, and height are three unknown values, but because we've done it in terms of the width, we only have one unknown, which means we only need one formula. Try and remember that. One unknown, one formula. That's why they talked about the length and height. We've drawn and labelled the diagram to display the prism. We've done that. Now we need to find the length of the diagonal of the base, which is obviously there. And remember, it is an isometric drawing, so it is actual fact a right angle triangle. So drawing that red one out, we have width of W and a length of 2W. So using Pythagoras, call that a so this is AC. So the length of AC, which is a line segment, remember, is the square root of W squared plus 2. Now remember, it's all 2W squared, which will give us 4 plus 1 is 5 lots of W squared. And if you want to, I can square root the W. So it'll be root 5, make sure you stop, and to the side, its length. So we've done part C. Now calculate the length of the diagonal within the prism. Now that was just what most probably, I think most of you got stuck on. What they want now is they want that diagonal going from one corner right opposite and to the top of the other. Obviously this is the longest length, and this is where you should trigger your memory that the longest length, of course, is another way. Let's call that G. So the length we want is of the longest side, DAG. We can use this formula that I gave you. It's length squared plus width squared plus height squared. It's a shortcut, which means we have 2 all squared plus W squared plus the height, which was 3H all squared. They all add up to 4 plus 1 plus 9 is 14 root 14 W squared, or root 14 and the W outside. Now, let's use the triangle. I'll use it, I'll just draw it in so that you can see that if I use this triangle here, as you can see, I'm using that length there plus the height. So let's try using that. So I'll do it using that green triangle, which means, remember, this length here is in actual fact root 5W. This is 3W. So we can work out the length of DAG using those two, which is root 5 all squared plus 3 squared, which gives us 5w squared plus 9w squared. And as you can see, there's 5w's, and those add up to 5w. So in other words, there's the L squared plus w squared, L squared plus w squared. So the shortcut worked well. And we have determined part D. So that's root 14w. And now finally, they want us to work out that angle there. Clearly, I'm using this triangle here. In other words, I want to find that angle there. And clearly, we could use that, or we could also use that new known value. So let me draw that one again. Let's see if I get it. Go. So let's draw. Remember, I worked out it using that formula that I gave you, but you could have done it as a two-step process. Keep in mind this is 3w and this was root 5w. We want the angle that it makes with the base to the top. So labeling, we have hypotenuse. Always do the hypotenuse first, which is always opposite. I always like to do the adjacent next, and then of course that leaves me with the opposite. In fact, I can do all three. I'll just do two. I'll do O and A, O and H, sorry, O and H, example. So that's sine, sine theta equals H, sine theta equals 3 over root 14. So theta equals the inverse sine of 3 over 14. The alternative, of course, is I could have used, say, tan. That's actually I might use A and H. I'll do cos. So cos theta A over H. Cos theta equals root 5 over root 14. Theta equals the inverse cos of root 5 over root 14. Go into our calculator. We have calculator, see, calculator. So we had the trig button. First one was inverse sine, and that was 3 divided by root 14. Check that it's in degree mode, press enter, and we have 53.3 degrees. The alternative was to use the cos button. Remember, it's the same triangle, so all that, but this time it's what we have is root 5, jump out, divided by root 14, square root 14, press enter, and we should get 53. And I might as well do the last one, and that's the tan theta. Make sure you get the O over A. That's a common mistake. So based on the angle that we want, O was the 3 divided by the root 5. And guess what? The answer is 53 degrees. So I hope that is 53, or to the nearest degree, 53 degrees. Have a go at doing maybe question 9 if you haven't already done so. It's very similar using algebra mainly. Have a good day.